This is Darren Marchant with American Nomad News. Let's have a discussion about how to build a space station. Now, for a really long time, just about the only kinds of space stations that you see in the media, in the drawings that you've conceptual drawings and all that kind of stuff, is you see the module style, like Mir and Skylab and ISS and this kind of thing. You see von Braun, the wheel, big wheel. Right? And occasionally you see Dyson spheres, Dyson rings. This is like it. This is what you get to see. This is what people have thought of. But there's a whole nother way to look at space. And I'm not going to get into exactly how to do it all in one shot. I'm just going to start to break it down a little bit for you. So first off, let's take all that kind of thing, set it aside, and know that what's coming is related, but you might not catch on right away. Foam. Foam is a cellular structure. It's either open cell or closed cell foam. It's the very, very fine foam that you see in foam rubber or styrofoam, where it's actually cells within cells. So it's almost like the cells are filled. It's like the foam of the sea, where you see big bubbles. I mean, you go to the ocean and you look at that foam. It's a whole bunch of different sizes of foam or bubbles, and those bubbles can be like this big around, lots of them. So does the scale of the cells matter? What is it? If a cell is by itself, it's not really foam, is it? If it's just a sheet of cells, like bubble wrap kind of thing, it's not really foam, is it? Foam has these really nice characteristics of strength without rigidity. And while the individual components are dramatically weak, the overall durability, strength, ability to withstand stress and strain and wear and tear is pretty good. Now, in 3D printing and things like that, early on, they had these little tiny scaffold foams that they made, where they would 3D print these really fine, really tiny little scaffolds in triangular patterns and things like that. And it was with a type of plastic they could dissolve away. But then they would sputter coat it with gold or something. And then they would put it in a bath and dissolve out the plastic from inside, and they'd make these little tubes. Let's take that, set that aside. Now imagine that you have a machine on the moon. We'll skip how it gets there. There's a bunch of logistics you'd have to do to get there. Okay? And that machine produces one basic product. Okay? Or actually a couple basic products. A strut, a piece of tubing. Call it a meter in length. With flat ends, just squashed flat ends and holes in them. At a very accurate 1 meter length. And those flat ends are flexible with hinges. Bolts, wing nuts, lock washers. And the lock washers would be trapped with the wing nut. So you put the bolt through the hole of the strut, and with another strut or more struts, and you turn it down and you have an attachment. It's very simple. One form one layout of this makes an equilateral pyramid. It's 3 sides on all of the sides. It's a triangle on all sides. All the lengths are the same size. All the angles are the same size. Now imagine that instead of making a sheet of these triangles, like you might see covering a bank driveway where they drive through, sometimes you see something like that. Imagine that you build a foam out of it. You're on the surface of the moon, and it's bumpy ground, and you don't worry about that. Because you're building this foam, and you're jacking it up to be level with the gravitational field. Okay? Essentially level with the moon. And above that initial plane of cells that are equilateral pyramidal cells is layer after layer after layer. Why is this an advantage, and how can we use this? Now imagine we take these struts, and instead of attaching them all on the moon, we put them out in deep space. And we make, remember, they're only 1 meter long each. And we make a foam that is 1 kilometer in any dimension. Right? You just keep attaching struts out from a given point until it's 1 kilometer away. It's a foam that's almost spherical in 1 meter equilateral pyramidal strut pattern. It's incredibly strong, very, very light. Now let's say that you produce a void in the inside somewhere. You take some struts apart. You put it all together, and then you go inside and you pick a spot and you just take the struts out along the way, like a worm eating through wood. And you take those struts and you put them elsewhere. You attach them to the outside. You just move them. Now you have a space to work, to attach things. So inside that space, you attach plates, like hull plating. Let's say on the very outside, you cover the whole outside with hull plating. This geometry gives us other options. Centrifugal force is incredibly important for humans and other types of animal life, but isn't necessarily as important for plant life. And this is a very interesting fact. So parts of a station can spin, and parts of a station attached to those other parts that are spinning don't have to spin. You don't see this in von Braun. You don't see this anywhere else. And you can spin them at different rates. You can spin them inside of each other. So let's say that you have something that looks like a open cage Ferris wheel. Oh, excuse me, my foot's hurting. Okay. An open cage Ferris wheel inside of a pressurized foam environment. You have this kilometer dimensioned piece of foam, and it's all sealed with a skin on the outside that's aluminum and cloth and solar panels and equipment, whatever you want to attach on the outside. And the whole basic station relative to the solar system around doesn't spin. But inside, you have these Ferris wheels, and you spin them in opposite directions. So they counter that sympathetic motion. Go look up sympathetic motion. It's the whole thing. And inside those Ferris wheels, people can live. But they don't need shielding in the Ferris wheel itself. They need the shielding in the overall space station And the other life forms need the shielding, the plants and the fish and so forth. But the humans need strong gravity. It may not be the same case with other life forms that we benefit from having. So let's say we're growing microgreens, lettuce and mint and spinach and basil and all these kinds of plants, potatoes, all scaffolded in, right? And we have special fans that double as water pumps. And you put one fan all the way on one side and one fan all the way on the other side, and you put ducting in between. And you pull all the air and water from one side to the other, pushes it back through the ducting, separating the water centrifugally, and air with a high moisture content, but really not much water, comes out the other end. And around the whole station, you have little sprayers. So you have an aeroponic microgravity system. You might even spin the entire piece of foam at 1/10 of a G, with the Ferris wheels inside spinning at 1 G. So the humans and certain animals live inside a Ferris wheel that has essentially very low density. So the structure doesn't have to hold that mass in order to provide the service. And you can have kitchens, and you can have a little water hose coming through to the sink, and you can use a toilet that, has a flushing function, but you might also have a vacuum function for it. So you can use it whether this Ferris wheel is temporarily stopped for maintenance or not. And it's all very, safe to use and very familiar. And objects fall down. And inside that Ferris wheel, you really don't need that heavy shielding material and all that equipment and all that stuff and all the life support. The life support doesn't really have to be under centrifugal force. It's not necessary. You put it in the ducting somewhere, and it processes the water or whatever as it goes through. You can have fish tanks that maybe they operate at 0.5 G, half a G. So they don't have to spin as fast. They have to hold a lot of water, right, in order to have fish. But maybe those fish don't really need that gravitational force to be all that strong. You can test it out, find out. That gives us abilities that currently we're not thinking that we have. I'm at 13 minutes on my time here. So this is Darren Marchant for American Nomad News. Thank you. Please leave a comment and check out my other videos.